So with the analysis that we've performed in the previous two videos, we can now write out some equations for Gauss's law. These equations are extremely important to know, so make sure you have them handy at all times when you're doing questions, because you might need them either when you're trying to calculate electric field or trying to derive an electric field quantity from that. So we finally arrived at Gauss's law, and the first thing we want to do is define it. So Gauss law has two different definitions. There's one for materials that we use, and then there's also a general one that we use. So for materials, we use the integral of d dotted with ds, which you've seen before, and it's going to be the integral of epsilon naught E dotted with ds. And from our discussion of electric flux in the previous chapter 5.2, we know that the electric flux within a closed surface is simply the enclosed charge. So we have Q enclosed. So in general, Gauss law states that the electric flux, or the total electric flux, is going to be equal to the surface integral, which means we're integrating over the entire surface. And note that the epsilon naught has disappeared, but reappears as Q enclosed over epsilon naught. So this is Gauss' law. So some things to remember. Number one, Gauss' law is always true. And based on 1 over r squared, on the 1 over r squared nature of the force law. Number two, we must apply Gauss' law on a closed surface. Number three, the electric flux is always zero, but not zero, is always equal to Q within a closed surface, and the net flux is zero outside the surface. Number four, we can state this as the flux being equal to Q enclosed. Number five, ds is simply the normal to the surface and has nothing to do with charge distribution. And finally, number six, as we discussed in the previous lecture, if the electric flux is positive, there is a net positive Q enclosed and more electric field flows out. And if the electric flux is negative, there is a net negative Q enclosed. Because it's going to have an attractive force, and therefore more electric field will flow in. Should be flows. So these are just some important points to remember for Gauss law. Keep in mind it's always true. It's based on the inverse square nature of the force law, so you can apply it to all closed surfaces.